Hi everyone, I'm here in VCV Rack. We're going to talk a little bit about this particular application that we're going to use for assignment 3. And specifically what VCV Rack is a way to emulate analog synthesis as we've been learning about on a computer digitally. So we're going to just go ahead and get started. I hope that everyone has been able to get VCV Rack downloaded and installed okay, and that it's running properly. I know sometimes it has a tendency to be a little tricky on older machines, even on my computer. It's not the newest, but it's fairly new, a couple years old. It does make the fan run a little crazy sometimes. So do let me know if you're having issues with it. But again, hopefully everything installs okay. See the software installation page for instructions on installing this and adding the Audible Instruments plugin that you'll need. So I'm assuming you're starting from that point after having it installed and got everything working as it should be. So what we're going to start with is we're just going to dig through all these, well, not all of them, but a good chunk of the modules, at least the ones that we're going to use, using the core and fundamental sections of VCV Rack for the most part. So let's start with core. So to add a module, all I need to do is right click with my mouse somewhere in the open rack space here. So I'm going to right click, and we're going to look into core module first, at least one of them. So we're going to click on core, and we're going to click in audio. So this gives us a core audio device. We have this little module. We can move it around here. So what we want to do first is choose our device from core audio. Now you could be using Bridge, which we'll look at later, or a different audio driver, but I'm going to have core audio here on my Mac. It might be different on PC. But then I'm going to choose a device, and then you get a list of all the devices. So if you have an external audio interface, you can select one, like my PreSonus Quantum here. I can select channels 1 through 8 in and 1 through 8 out. I could use my Apple built-in output. You could use a built-in microphone if we're taking inputs. But right now, what we want to do is set up an output so that you can get sound to go out of your computer. So for most people, you'll probably just use your built-in output, and that enables, you can see the green dot here, channels 1 and 2. Once we patch cables into these two little patch cord jacks, whatever sound is coming from that should then be output to your computer. Set your sample rate. As we've learned, most of you probably just leave that at 44.1 kilohertz. That's all we really need to worry about, but if you did want to change that, you could set that there. So that's the idea with this core audio module. Now I have to do something a little bit different here because I'm recording the sound from this program as well as a microphone right now. So I'm actually over here on the right, I've got this set up so that I'm actually running sound into channels 1 and 2 of something called Soundflower, which routes whatever sound is happening on the computer currently. And I'm routing that output to the Quantum so I can hear it through my headphones. And this Soundflower input then goes into QuickTime, which is what I'm using to do the screen capture recording here. So mine look a little bit different than yours, but you essentially just want to have a core audio with built-in output set as the device here. So with that being said, I'm going to delete mine by clicking on it and hitting the delete or backspace key. That's good to go. And I'm going to bring this over here since this is what I'll be plugging into. So ignore this and ignore this. Yours will probably say built-in output or whatever output of an external interface that you have, and will you be using channels 1 and 2? Everything else from there should be the same for you from what you're looking at. So what I'm going to do now is right click and go down to the fundamental modules, and we're going to add a mixer to start off with here. And a couple of things to notice right off the bat with VCV Rack. First of all, our outputs are black and our inputs are white. So same thing with the core audio here, and same thing goes with all the modules. Anytime you want to output something, you'll pull from an output jack that has black around it, and any of the inputs are not going to have that color surrounding. They're just the regular white inputs. Another quick little thing to mention here, CV stands for control voltage. You'll see that on a few of the modules. We'll maybe get a little more into that. But anytime you want to control something with a control voltage, plugging a taking a CV output from a module and putting it into a CV input will let you control that particular device. So on this device, you could control each individual channel's volume or the full master volume or level. So one thing we want to be able to do is plug sound into here. So here are our inputs for sound, the ins, as you can see here, right? And then we want to get sound out. So you could take each individual channel and just click and drag a patch cable. You could do that, channel 1, channel 2. But actually, the best thing to do here is to take the full mix. So you could have up to 4 sounds coming in here, all mixed using these sliders here, as you want, and then take the sum of that out here. So we'll take the mix, we'll drag one over. Well, so I can't actually drag 2 from one single output, but you could drag from the input here over and have this mix sending to channels 1 and 2. So there we go, and there's our master volume. Let's turn it down for now. So anytime you're starting, you'll probably want to at least just get your audio set up and a mixer set up. Okay, what else can we do here? Well, let's kind of start going through some of the ideas we've talked about in the synthesis lectures. Let's start with a VCO. So I'm going to right-click, go to Fundamental, and I'll use VCO 1. And here is our voltage-controlled oscillator, right? So here we go, white input, black output. We can see those there. We've got a frequency knob, fine, P-width, FM-CV, PWM-CV, analog digi, hard and soft. We'll go through all of these here momentarily. So the biggest thing we want to do right now is probably just take an output and see if we can get some sound. So I could choose to have a sine wave, triangle wave, sawtooth wave, or a square wave. So let's just hear that. There we go. Cool, there's our sine wave. Could take a triangle and the sawtooth. Let's turn that down. And we could have a square wave. So we could have all of the waveforms coming out of the single oscillator and mix them at the mixer here. Okay, great. Let's take some of these out just so we're not... Let's just do the saw wave. There we go. Now if I want to change the frequency, I just click and drag this knob. Now, I believe I mentioned this before, but just in case I haven't, generally in computer programs, if you're seeing a knob dragging just straight down, we'll drag the knob to the left, and dragging straight up, we'll drag it to the right. Don't try to drag in a semicircular motion. It tends to be harder than it seems like it should be. So up and down. So there we go. I can have this frequency. Now the fine knob here, this allows you to fine control that frequency. So this is sort of a coarse frequency control. If you wanted to tune that, you can use the fine knob. If we were to take a square wave, the P width or pulse width, you can control the pulse width there, like we talked about in the synthesis lecture. Okay. So what else do we have? Well, we have this analog or digi switch. Let's bring this back in. It doesn't do much. The analog tries to emulate a bit more some of the uncertainties of analog synthesis, so I would keep it on that, but you can play around with it. The hard and soft, you can play around with those as well. But it doesn't really matter for what we need to do, so I'm going to kind of leave that out for now. I should mention here, your main input for a VCO, if you want to come into an input, which we'll look at here in a moment, that's the V/oct, or volts per per octave, 1 volt per octave. This basically means that to raise the pitch an octave, you need to send 1 volt. To go 2 octaves, 2 volts, etc., etc. So if you want to actually divide that up into 12, so you have the 12 pitches, you would be sending basically 0.12 to move up a half step or 1 key on a keyboard. So that's the idea. That's your main pitch control input. That's the V octave, right?